This, we're going to do a tiny bit of notes, and then you're going to play with actual algebra tiles. I think you're being a little sarcastic, but I do not care. I am still going to make you do it because I am the boss of you.
That scares me.
Why?
I don't know.
Okay.
It just really scares me.
All right. So again, now, ladies and gentlemen, I have done something that I don't normally do. When I taught you how to do this, I showed you a way to do it, and I didn't show you any other ways. And there's a reason I didn't show you any other ways. Because sometimes, with 21 years of teaching something, I have recognized that there are many ways to do many questions, but sometimes when I show you more than one way, kids tend to sometimes latch on to one of the other ways I show them how to do something, and then they never ever do the question right, which is a bit of a problem. You can't say, I don't like to do it your way, I like to do it this way, when your way is wrong. Do you understand what I'm saying? I shouldn't say that. Not when your way is wrong, but when you get the wrong result. Does everybody understand what I'm saying? Like, you couldn't drive down the street and say, I don't want to drive on the right-hand side of the street. I want to drive on the left-hand side of the street. Would you still get to where you are going? Yes, of course you would, but it would be harrowing on the trip. Understand? So normally, as always, I try to show you many different ways to do problems, but polynomial multiplication really, I find you get better results when you do what I taught you to do, which is written on the backboard, when you stack them up. But again, I don't care if you don't do that. So this first one, the answer is, of course, x squared plus 2x minus 12. So you can give yourself, what? Oh, of course it's 35. Minus 35. You can give yourself 2 marks for that. I don't care how you got it. Of course, what you should do, though, like I say, is do the first 2, x squared plus 7x. Then do the second 2, minus 5x minus 35. And then add them up. X squared plus 2x minus 35. Okay? Again, though, do whatever you are comfortable with doing. Okay? I think probably because if you didn't get the right answer, you're going to be like, ugh, how much do I give myself out of 2? So I guess I will quickly go through all of this. This is 6x cubed plus 9x squared minus 10x minus 15. And you'll notice I didn't stack them up because there were no like terms. You got to leave it like that. Down here, 28x squared minus 7xy. And then I have plus 8xy, so I can stack them up, minus 2y squared. And you get 28x squared plus xy minus 2y squared. Okay, so you need to see where you're getting something different from me. 7 times 4 is 28. X times x is x squared. 7x times y is 7xy. 2y times 4x is 8xy. And 2 times 1 is negative 2y squared. Then you just add it up.
I just forgot to do the rest of the question.
I see.
I guess I did like half in class.
All right. This one, of course, some of you, even though I went over it to death, some of you are still going to tell me this answer is 9x squared plus 4, which is, of course, wrong. That squared means you have to do the base twice. And here we are back to double distribution, which is, of course, 9x squared plus 6x plus 6x plus 4 to get 9x squared plus 12x plus 4. And all of these are, of course, worth 2. This one is cubed, so I got to have 3 of them. Now, doesn't matter what you do, but you have to start with doing 2 of them. I always like to start with the second 2, but you don't have to. So since we're starting with the second 2, I'm not going to do anything with the first one. I'm just going to do this one here, which is, of course, 4x squared minus 10x minus 10x plus 25. Then, what is going on with this thing? 2x minus 5. And then I tidy up this. 4x squared minus 20x plus 25. And then, of course, I have to do this guy times everything. So there's going to be 3 terms. And those 3 terms are 8x cubed, because x squared times x, or x times x squared, minus 40x squared plus 50x. 2x times all of that. Then I have to do negative 5. And a lot of you are going to forget that negative. That negative 5 has to go in there 3 times, which gets me negative 20x squared, and I keep my x squareds together, plus 100x, because negative times negative is positive, then minus 125. Then you just add it all up to get a final answer of 8x cubed minus 60x squared plus 150x minus 125. And that's your final answer. And then over here, it's the exact same thing, except you don't have to do the first step. It's just x all the way through, 2x cubed minus 4x squared y plus 3xy squared, and then the y all the way through. 2x squared y. Oh, there's x squared y, so plus 2x squared y minus 4xy squared. There's my xy squared, so they go together, plus 3y cubed. And then you just add it all up. 2x cubed minus 2x squared y plus minus xy squared plus 3y cubed. And lastly, these 2 look really difficult, but of course they are not, because it is simply exponent laws, yes? This one messes kids up because of the way it looks. So again, I'll use some color, because color always seems to help. There is one term, there is a second term, and there is a third term. How do you know each of those are their own single term? What is it about those, what's inside those brackets, that lets you know that you need 3 different colors in there? Jacqueline. It's separated by plus and minus. So if there's 3 different colors in there, how many arrows do I need from out here? 3. There's the first one. 8x cubed y cubed. There's the second one. Negative 4x squared y cubed. And there's the third one. Plus 2. What do I do with the exponents there? We just wrote a test on it. What do I do with the exponents there? What's 2 plus negative 1? 1. 2x. And what's 3 minus 3? 0. So do I write it? No, because y to the 0 is 1. And now it is done. Over here, same thing. 1 term, 2 terms, 3 terms. That should have been blue. 3 terms. So I need 3 arrows. There's the first one. 12, x, 7, y, 8. Because you'll notice I messed with your order here, right? That's just to see if you're paying attention. Minus 28, x to the 6th, y to the 6th, and plus 32, x cubed, y to the 12th. Because 6, or y to the 8th. Jeez, dummy head today because it's Monday. All right. 1, 2, 3. Now, ladies and gentlemen, I cannot stress this enough. These are the things that are going to screw you up in this unit. Because let's be honest, the math really shouldn't be screwing you up in this unit, should it? Because it's never more than multiplying 2 things. And do I let you use a calculator? So, none of these should ever be wrong, should they? Right? Ever. Because you have a calculator. Even here, if you have to add them, should they ever be wrong? No. Negative 4 plus 2. You can use your calculator for it. You shouldn't need to, but all of you have been so wrapped and bathed in your calculators that you think you can do no math without them. I can't break you of that habit in the 3 months that I have you here, except to continually tell you you don't need them. So, the issue is going to become up in this part of things, right? Not understanding the concept of distribution. Because if I ever ask you to multiply 2 numbers, you could do it in your sleep, right? So this is the new part. You have to decide what works for you, especially up in these ones that are doubled, right? There is no shame in drawing the arrow and writing the answer. At all. None. As a matter of fact, I highly recommend you do it until you get every one of these pages 100% correct. Then you could consider not drawing the arrows. But it's up to you. Okay? Everybody good? So give yourself a mark out of 16 on that, and I'll come around and get it a little later today. While you are messing around with these little blocks, I will come and get it. Okay? Then I would like for you to turn over the page to, I believe we are on page 59, yes? All right. So what's going to happen is I'm going to talk for a little bit, and then you're going to get into groups of 3 or 4 and come get one of these little baggies. Okay? But I'm going to talk a little bit first. What math is happening here? What math's happening there? Multiplication, absolutely correct. Right? How do you know? Pardon me? I got to distribute the 4. But how do you know to distribute the 4? It's outside of brackets. And there's no sign there, yes? And when there's no sign there, we know it's multiply. Right? Okay, so we know we're multiplying. Now, Gersel said I got to distribute the 4. But let's pretend you haven't been paying attention for the last 4 days. You have no idea what that means. So, Gersel, what does that mean? What do I have to do with that 4? So I have to multiply it by x. And then, because plus is the math equivalent of and then, 4 times what? Negative 5. To get an answer of what? 4x plus negative 20. Now, math guys, we know math people are lazy, right? We know that they don't write 2 times 2 times 2 times 2. They write 2 to the 4th, right? So no math person wants to do a plus, a bracket, a negative, and then another bracket. How do we, as math people, what is the lazy way we have invented to write this? Jacqueline. 4x minus 20. Because, of course, subtraction isn't a real thing. Subtraction is adding negative numbers, and we have gotten too lazy to bother writing it out properly. Is everybody good? All right. This direction has lots of names. We're going to call it expansion. Because we took a monomial and a binomial, and we ended up with a single binomial. Everybody cool? Easy peasy lemon squeezy, yeah? Right? Now, what do you see there and there? This is not a trick question. What do you see? Addison.
4.
You see a 4 in both cases, don't you? And what math is that 4 doing to the next term? Multiplying, which means 4 is a factor or a product. It is a factor because it is part of the multiplication operation, yes? Now, since that 4 is in both of these terms, is it not a common factor? Yes, because what does common mean? Kinda. What does common mean? Not quite.
Used a lot.
Getting warmer. That's one definition of common. I have 2 eyes. You have 2 eyes. We share that in common. So this term had 4 as a factor. This term had 4 as a factor, right? So that means if you can expand that 4 that way, what would happen right here if I took that 4 out? That part going this way is what we call factoring. And what that is, it is the reverse. 4x minus 20. Is that a factor or a product? It's a product because we just did the multiplication, didn't we? So now let's reverse it. How do we reverse it? Well, to get there, we had to multiply in a common factor, yes? So how would we reverse it? You would divide, instead of multiplying in, you would divide out the common factor. So we know that 4 goes into both of those, and we end up with 4 times x minus 5. Everybody good? All right, now you're going to see this. It gets way more complicated than that, but that's the basics. All right? Now, this one right now, is that factors or a product? That is factors. How do you know they are factors, Jacqueline? Because I am multiplying this binomial times this binomial. And why do we know it's a binomial? Because it's encased in brackets, yes? So no matter what I write in there, it's all one thing, right? Okay. So can I right now do dark green expansion or light green factoring from that? I can only do expansion because it's already broken down into 2 factors, right? So all of you expand that for me. In whatever way you want. You have a shortcut for that because it's just x and x, or you can write it out this way, or you can write it out stacky, the way I like to write it. Your choice. everybody expand that. I, of course, will do all three. And the shortcut. Everyone is good, yes? Now, you're intelligent young people. If I can get to here by expanding, there must be a way to take trinomials and break them down into factors, right? And that's what we're going to work on today in a moment with these little baggies. Right? Okay. Next thing. This year, we went back in time to grade 4 or 5, and we did factor trees of numbers, yes? Right? And you all remember, and I'm just going to write it right here. You don't even have to do it. 3 times 4, 2 times 2, right? That is one way to factor 12, yeah? In this unit, we're going to use only pairs of factors of 12. Not just 12, all the numbers we are dealing with, okay? So I need any two numbers, all the pairs of numbers that will multiply together to make 12. I gotta know. I'm sorry. Talk to each other. What are all the pairs of numbers that are multiplied to make 12? So what are the numbers that will multiply to make 12? What's the easiest pair, Jacqueline? 1 and 12. The one everybody forgets. Is 1 times 12, 12? And if they multiply together, are they factors? How many people forgot 1 and 12? Be honest. It's no big deal. Okay, what's the next one?
2 and 6.
Yeah! What's the next one? 3 and 4. Yeah! Now, ladies and gentlemen, are there other numbers that we could use to get to 12 other than them? Yes, what are they, Gersil? Decimals and fractions, yes? But in this unit, we only care about pairs of integer factors. Everybody cool? Everybody good? Okay, so we're going to do something slightly different right now. And I'm going to give you one of these baggies. Now listen to me, please. I know it seems stupid in this day and age of modern technology, but these little baggies are idiotically expensive. I do not know why. They are pieces of plastic, but they cost a crap ton of money. So don't mess around with them, okay? People already have, like this bag has almost nothing in it. This bag is super full, right? Don't mess around with them, okay? So get in a group of 3 or 4, come get a baggie, and we'll talk about what we're going to do with them when you're back at your desks. All right? Go.